Well, good morning and welcome to today's webinar, Strengthening Your Security Operations with Automated Workflows. If you are a returning guest, thank you as always. And if this is your first event with us, thank you for joining. Before we get started, a reminder that you can submit questions in the available fields. We do have a lot of information to cover and some use cases to discuss. So if we aren't able to answer a question during the webinar, all questions are captured and we will reach out to you after the event. Also to note, there is a post-webinar survey that will give you an opportunity to provide feedback and schedule time with the Security Services Group if you do have any questions or would like to follow up. So in working with our clients on a daily basis, our Security Services Group felt very strongly that today's topic would be very relevant. Given the response and number of you in attendance today, that assumption seems to be correct. So given that, I am confident that you'll gather information today that will be useful in hopefully developing or enhancing your SOAR strategy moving forward. So with that, Jacob, if you don't mind, we'll get started. So today's goals, as always, number one, provide insight and information that is new to you. Hopefully this information is relevant to your needs, particularly if you have a current need, and we'll get to some of the pre-event survey questions that'll sort of touch upon that. And lastly, as always, demonstrate our ability to partner with you in whatever capacity that means. So we'll have introductions in a moment. Jacob's going to go into great detail on how to secure your operations through SOAR. We'll have some great use cases. And as mentioned, Q&A available as well. So if I had to summarize the theme of today's content, it is alert fatigue. Whether it's security teams being understaffed, new and more sophisticated threats, the complexity of managing just multiple data ingestion points, or simply the sheer volume of dealing with false positives, alert fatigue is very real and a significant issue for companies. This was a recent article that I found interesting because it sort of outlined, Jacob, there you go, it sort of outlined 3 areas that are going to be relevant to today's conversation. Number one, I think we all know this, it's tough to find talent, it's tough to find resources. That's going to continue. I think the most of us are experiencing that work from home becomes the norm, and that has introduced a whole bunch of new variables associated with strengthening our security posture. And this last part about automation, what we'll focus on today, is that it can become a very important part of our security strategy. So we're here, we understand this, we're here to help. And today, again, we'll be talking about SOAR, orchestration, automation, and response. So in working with our clients in implementing SOAR, as well as leveraging our own MDR offering, we'll see that in a moment, we've sort of found a number of common benefits with our clients. Number one, priority. It's obvious that the impact and frequency of cyber threats is increasing, and the tools that we put in place need to evolve to keep up with that volume and sophistication. And what we're finding is without a platform that can separate sort of the signal from the noise, that teams will waste a lot of time and money trying to keep up. A SOAR platform can act as that collection analysis hub that make triage and response more manageable. Talent shortage, we talked about that. Automating processes through SOAR can remove a lot of those mundane tasks. And what we're finding is that can really curb burnout, which is a very real thing today. Workflow management. In a lot of organizations, we have different skill groups with different roles. And the ability within SOAR to sort of provide workflow management is very valuable because now we can have those organizations, those resources working together in harmony as opposed to sort of acting in these silos, which makes it difficult to respond effectively. On that note, efficiency, good data drives better decisions and outcomes, but this data needs to enable the right action at the right time to be effective. And we find that, again, SOAR platforms can increase that efficiency by running that automation, showing value. Oh, sorry, Jacob, showing value, the interesting one. This one is near dear to my heart. So I think for a long time, it's been tough for CISOs and security directors to show value to stakeholders in the company. Security has been always seen as a cost avoidance, if you will. And if nothing's happening, sometimes it's hard to demonstrate value. So what we're finding is with SOAR, we can actually implement quantifiable metrics that show the impact and efficiency. So instead of pointing to the avoidance of a negative outcome like a breach, we can point to measurable outcomes like mean time to respond. I think Jake is going to talk about that at the end here. Mean time to detection, or analyst hours saved because of automation. So if you're having trouble trying to show that value, SOAR can be something that we can implement pretty quickly and help you do that. So what is our team, our security services group, seeing in the field with our clients? Many of those same things I touched upon. So organizations struggle with just alert overload and fatigue. The hiring of new talent is difficult. Emerging threats are changing daily, and it's tough to impossible for internal staff to keep up. Correlating multiple data ingestion points is a big one. All these different products out there, how do we correlate that data to quickly act? And related to that, how do I prioritize those alerts so I can execute a proper response? So before the event, we had a few registration questions, and I always find these interesting because it's measuring what you guys have for data. So out there with your peers, do we feel that automation is being fully leveraged in your organization? So today, almost 70% saying no. Conversely, do you have a directive to implement automation this year? And almost half are saying you do. And you're here today because 80% are saying we don't know today how automation can be leveraged in our security response. So again, very timely webinar, I feel. So do you have a SOAR platform in place today? 80% are saying no. Again, I think that talks to today's attendance. Do we have a SIM in place today? A little over half do not. And lastly, do you work with a MDR service provider today? And 60% saying no. So I think good numbers to talk about where you are today. So before I hand it over to Jacob, particularly for those that haven't been part of these webinars, I'll just take a few minutes to highlight New Era. So you can see 60 offices worldwide, 3,000 plus employees. And to the right, you can see the listing of our services. And Jacob, if you go to that next page, we'll see that listed out. Today, we're focusing on the security and managed services practices, but just know we can support that entire stack. So collaboration, for example, really big part of our practice. Certainly data networking. Cloud Blue is our hosted collaboration services. So anything from contact center to unified communication to video surveillance, all part of a monthly managed services with an SLA. And from beginning to end, we are really at the heart of it, a professional services company. So to help you design, understand what a solution might be, implement that, and then support it once that's installed. So as I mentioned, today we're talking about the security practice, which is really broken up into 3 areas. I'll quickly just show these. Again, we can talk about these in a little more detail after the event. But our advisory services practice, you can see those offerings listed, penetration testing, vulnerability assessments as an example. If we move to the next slide, Jacob, you'll see our managed security infrastructure practice. So again, if your team is having a just difficult time with resources or time, you can work with our organization and we can manage these different technologies in your environment. And lastly, we'll be touching upon today a little bit our MDR practice, managed detection and response. So, again, Jacob will talk about, we've heavily invested in Soar in our ability to support our clients. So this service will provide all these different data ingestion points and will act as that MDR provider for you. So with that, Jacob, I'll turn it over to you and let you introduce yourself, and I'm very excited for today's content. So in advance, thank you, Jacob.
Thank you, Joe, for the introduction, and I'm happy to be with all of you today. As Joe mentioned, we have a service called MDR, which utilizes automation heavily. And when we were designing that service, MDR, and as we continue to make enhancements to it, we are always planning for new opportunities to use automation. So as we go through this webinar today, what I'm going to be showing you is really the same process that we go through when we decide that there is opportunity for automation. And we're going to look at how we take that entire process from beginning to end, identifying the use case for automation and actually creating the automated workflow. So to quickly summarize what Joe has already mentioned, here are issues that are not unique to any one organization. Every security team is facing these issues when it comes to their security practice, having a large set of tools. Of course, all of these tools provide some value, but they can also create a lot of noise. And that leads to alert fatigue. And when you have alert fatigue, you end up with slower response time because of issues of not having enough resources on your team to respond and triage quickly and adequately. And when you have a slower response time, you're potentially introducing more risk to your enterprise. Another issue is lack of standardized response. So of course, humans are not perfect. We do make mistakes. And especially when we are stressed or overworked, there is an increased possibility of responding to an alert incorrectly or deviating from procedures that we've established. When that happens, we potentially could miss alerts completely, or we could not investigate an alert fully, and we can introduce more risk to our organization. So that's why we need automation in security. So before we get started with actually planning workflows, I do want to touch again on a little bit about what Soar is. Of course, I'm sure if you live in the security world, you've heard this term before, but let's take a look at exactly what a Soar platform is. So, as Joe mentioned, Soar is security orchestration, automation, and response. And there are several vendors that sell Soar solutions, Soar platforms. I've listed some of them that you may be more familiar with here on this slide. Some examples such as Cortex XSOAR from Palo Alto, Simplify, Splunk Phantom, Swimlane. There's many more that I could not list here because there's so many of them. But what I want to do is actually challenge you to not think about Soar only as a product or as a type of software. We want to think about Soar a little bit more broadly and generically as a concept and a strategy. So all of these vendors have created Soar solutions, and they package all of the components that Soar consists of for you for your convenience. But we don't necessarily need to buy a Soar product to start thinking about Soar workflows, Soar strategy, Soar concepts. So with that in mind, let's establish what really is Soar. Well, it is a collection of different softwares or tools that are used together to integrate with your suite of security tools. So we want to have the ability to take any tools that already exist within your organization, whether that be firewalls, EDR, threat and vulnerability management tools, IPS, IDS, whatever it may be, and have one central platform that gives you the ability to interact with all of these different applications. We also use Soar to define standard procedures. These procedures could be related to many different aspects of a security operations team. So it could be related to incident response, and that actually is going to be our primary focus today. Throughout the rest of this presentation, we're going to be looking at the perspective of a SOC and what they would do to use Soar to assist them with their incident response. But it doesn't have to be limited to incident response. We could have procedures that are related to things such as threat and vulnerability management, threat intelligence management, generating reports, or even maybe performance monitoring of our different applications that we use within our organization. So we're able to define those procedures, and we are able to automate them to make our operations more efficient. So with that in mind, let's talk about what our goals are when we establish automated workflows. Again, this is from the perspective specifically of incident response, but in general, I'd say it applies to many of the other use cases as well. So Joe touched on this a little bit already. Our primary goal here is we want to reduce mean time to respond, or MTTR. The way we're going to do this, we're going to integrate with all of our different tools, all of those consoles that right now your analyst and your group needs to log into manually to interact with and learn how to manage. We're going to put that in one system, give us a central plane of management. We're going to aggregate any alerts or data that those tools have to offer. We're going to enrich alerts whenever possible with additional information. What we want to do here essentially is give analysts all of the information they need to hit the ground running when an alert comes in. We don't want them to have to spend time on menial tasks. We want to automate those time-consuming tasks and really make sure that our analysts are actually spending as much time as possible performing analysis. The more time we give back to them, the more value we're going to get back from them as part of our security operations. And again, we want to reduce errors, right? So there's always possibilities of humans making mistakes. Automation makes mistakes less often as long as it's designed well. So what we want to do is reduce the risk to our enterprise, and we do that by ensuring that our standard procedures are followed. All right, so we're going to actually get through planning some workflows around some use cases within incident response. But before we can do that, there's a couple things we have to go over to make sure we understand what a Soar platform actually entails and what resources we're going to be interacting with as we design these different workflows. So let's talk about what components actually make up a Soar platform. Again, if you purchase a Soar solution from one of these popular vendors that we talked about a few slides ago, all of these components will be packaged for you within that platform. But you most likely already have tools and applications that can fulfill some of these purposes that could be integrated in a way to produce automated workflows. So let's talk about specifically what things actually are taking place and interacting with each other during a Soar workflow. First, we need some sort of runtime environment. Automation is the backbone of a Soar platform. Of course, we need a place to run automation scripts. So this really is the most critical piece. Whether it is a physical server, a VM, some form of serverless code from a cloud provider, Azure, AWS, and GCP all provide some version of serverless code. We need a place to run our scripts. Then all of these other resources are things that our scripts will interact with as they are being executed. So secrets manager, for example, we need a place to keep track of any credentials that we'll be using to authenticate against all of these different tools that we want to integrate with. Database, so there's going to be a few different use cases in which we will need to interact with a database in our workflows, and we'll touch on those as we get to them. Ticketing system, so this is wherever your analysts currently are working out of, where they're tracking their progress and recording notes related to the incident response process. And finally, there's going to be a variety of tools which I'm representing with this final icon. And these are the tools that we want to integrate that are part of your security suite currently, things such as EDR tools, firewalls, whatever it may be that exists within your organization. So we're going to keep these icons in mind. As we get to later parts of this presentation, we're going to refer to these icons again to help demonstrate visually how these different resources interact with each other, how they come into play when we're building an automation workflow. All right, so we're almost at the point where we can begin planning our workflows, but before we do that, I do want to level set a little bit, make sure we're all on the same page here and understand what we're talking about when we say that we are integrating with another application. We do that using an API or an application programming interface. So if you come from an automation background or a computer science background, of course you are extremely familiar with this, but in case you're not, let's cover the basics here. So an API is what establishes a way for us to programmatically interact with an application. I'd say most applications have APIs, but not all of them. So that actually is something you're going to want to consider when you are looking at new software or new tools that you want to bring into your organization. You want to make sure that when you are POCing those tools or talking with those vendors, that you ask them and understand if they have an API, and make sure that it is well documented, because if the tool does not have an API, it's going to be very difficult or much more difficult to interact with it in a programmatic way. And we don't want to have a tool that we are forced to only interact with manually. But in most cases, APIs are available, so we're able to use this form of programmatic interaction. So the way that we interact with an API is by sending it HTTP requests and then receiving HTTP responses. There's a few different components to an HTTP request, so I want to show you these different components, and I'll refer to them later on, but we won't have to think about all the specific detail later on because we're going to cover what this actually consists of right now. All right, so let's take a look at this HTTP request first. As I said, there's a few different components to this request. Here in the darker blue is what we refer to as the request line. The first piece of this that we have is the HTTP method. In this case, this is a GET request. So I'm going to show you actually two examples of HTTP requests. Right now we're doing the GET request. I'm going to also show you a POST request. They're used for different purposes. So as the name implies here, a GET request is what we use when we want to get information from the application that we're sending the request to. Right after my method, I have the specific resource on that application that I want to interact with. In this case, it is a resource named alerts. So in this example, I am requesting information referring to the alerts that that application holds. Then I have my specific version of the HTTP protocol here. If you look now below to the second box, here are my HTTP headers, and these have some additional information about my request. What is really key here is this authorization header. This is how, in this case, I'm actually authenticating to that application, how it knows that I do have permission to receive the information that I'm requesting. This may not always look exactly like this for every tool. The API, as developed by those that created the application, will differ from tool to tool in how they want to receive this authentication information. So this is one very common example, but it could look a little bit different depending on what tool you are integrating with. I do also want to mention, here it looks like we have credentials in plain text, but keep in mind, just as when you open your browser and you are, perhaps not consciously, but you are sending HTTP requests to different sites as you web surf, we'll be using HTTPS, which means that this will actually be encrypted in transit. So this plain text password or credentials will not actually be visible as it is traveling to that application. All right, let's take a look at the HTTP response. Similarly to the request, it has these different components and they actually are quite similar. So first up, we have the status line here. And what's key here to look at is the status code. Here we got a status code of 200. That's good. That's what we want to see. A 200 code means that the request was understood and the application was able to respond to us. You probably have seen, I'm guessing, a few other status codes through your web browsing, things like 404 meaning not found, 403 meaning forbidden, etc. Typically, if we see any status code that does not begin with a 2, that means there's some kind of error and we'll have to do some troubleshooting. Below that, there are the headers, similar to the headers that we saw in the request. Finally, in this case, because this was a GET request and we wanted to get some information from the application, we have now in the response a third component called the body. And the body actually contains the information that we requested in this case. So here's some information about the alerts that we wanted. All right, if we go to the next slide. Here, very similar, so we'll just run through it quickly. This is a post request. So unlike with a GET request, in this case, we actually want to send some information or some directives to this application that we're integrating with. Looks very similar though, right? We still have the request line. In this case though, my method is post. Still have headers because we still need to authenticate. But now we actually have a body within our request instead of in the response. So in this case, I am telling the application that the alert with ID 123 should have its status set to resolved. If you look at the response, again, very similar. Even though we're not requesting information in this case, we still want to look for this status code that we got, 200. That lets us know that our request was understood, that we did have the correct permissions to make that request, and that it was implemented successfully. All right. So with that in mind, we're actually ready now to jump into building some automation workflows with everything that we have just covered. So we're going to actually approach this in 3 sections, and there are quite a few different use cases within each section, but we're going to take a look at one in particular for each of these 3 scenarios. So we're going to go through automating process management, alert enrichment, and containment actions. As I'm sure you know, all 3 critical pieces to an incident response cycle. And let's start off then with process management. So here's what we're going to do. For each of these scenarios, we're going to start off with a description of what you are likely facing in your organization or what you're seeing across various organizations. So before I jump into this, I do want to mention, for those of you that said you already have automation within your organization to some extent, this first use case we're going to talk about is probably what you have already automated. If you don't currently have automation, this is definitely the first use case you're going to want to implement. It is maybe the simplest use case, but also the most critical in reducing any potentially missed alerts and really saving time for your analysts, automating some menial tasks. And even if you have already implemented automation for this use case, we're going to take a look now closely at actually what is happening behind the scenes, how these integrations are working to make this happen. So let's say that we have a SOC that monitors several alert sources, such as an EDR tool, firewalls, SaaS platforms such as Microsoft Office 365, and currently all of these alerts send emails to a team mailbox when an alert is detected. The analysts then manually create tickets to track the incident in a central platform. Sometimes emails are inadvertently missed, and to manually create the tickets, the analyst often must log into the system that generated the alert to gather additional information. And finally, when the ticket is closed, analysts have to log back into that originating system that generated the alert and close the alert there as well. All right, so that is the scenario that every organization that has a security team is dealing with, right? So now let's go through the process of how do we actually go from that scenario that has a lot of manual time-consuming work and change it into an automated workflow. So the first thing that we want to do is identify our procedure for this use case. So here, I actually don't want you to even think about automation yet. You don't want to just skip all the way straight to trying to automate without actually planning what that procedure currently looks like and where the opportunities for automation are. So in this case, what you want to do, work with your security team and write down what actually are they currently doing manually. So in this case, for the scenario we just spoke about, the first thing we do is we query each security tool for new alerts, or perhaps you search in your inbox for new alerts if you're getting notifications from those tools. Then they create a corresponding ticket with all of the information needed for the investigation. And finally, when the ticket is closed, they also have to go back into that originating security tool and close the alert there as well to ensure that the statuses between the ticketing system and the security tools are in sync, and that we don't just have a bunch of open alerts in those tools that actually have already been investigated. So now that we have this, we've established our procedure. Now we're going to start looking into how we can take this procedure and automate it. And what we're going to do is we're going to work on writing pseudocode. So pseudocode, as it sounds from the name, is not actual code, but it is a notation that resembles a programming language, and it's used commonly in program design. And so what we want to do here is actually take those steps, those manual steps that we establish that we know are currently being performed, and we want to take those and actually break down what is our automation script actually going to have to perform, what specific actions need to take place, in what order, and how do the results of each action, how are these results actually referenced by future actions to accomplish that manual step. So we don't need to go through all of these because we're actually going to go through it again in a more visually friendly way in a moment. But as an example, let's just step through one of these. So if you look at querying security tools for new alerts, for example, that may alone sound like a very simple basic step, but in reality, there's quite a few different actions that need to take place in order for this to happen. So for example, the first thing that our automation script is going to have to do is get the credentials that it needs to interact with whatever tool we want to collect alerts from. We also then need to get a checkpoint value. So what is a checkpoint value? It's basically a bookmark. What we want to avoid is we don't want to have duplicate alerts in our ticketing system, right? We don't want to end up every time we run this automation script, we don't want to pull back the same alerts time and time again and create tickets that are referring to that same alert. So our checkpoint value will hold a timestamp that lets us know the last time that we performed, that we executed this automation script. And then using that checkpoint value, we can have our script make a comparison between the time that each alert was created and when we last performed this query. And we can make sure that we are only working with alerts that we have not previously already handled. And then in this case, we would also then want to record the new checkpoint value to prepare for the next run of the automation script. So we want to make sure that whatever we're pulling right now is not going to get pulled again on the next execution. Again, here's some pseudocode for the other two steps as well. I'm not going to go through them all in too much detail right now because we're going to speak about this in a little bit more of a visual way in a moment. Okay, so at this point, we have talked about our procedure. We've already taken the steps to write some pseudocode and translate that human-friendly procedure into what our automation script will actually resemble. So with that in mind, we've now started to discover some of the different resources and components that we need for this workflow to take place from beginning to end successfully. So let's look back at these components of a Soar platform that we talked about earlier and see specifically for this use case, for this workflow that we're working on right now, how are all of these different resources going to come into play? Of course, we always have our automation scripts. As I said, that is the backbone of a Soar platform. That really is what is going to be controlling the logic and flow of this workflow. We also have a secrets manager, right? So in this case, we're going to need API tokens to be able to authenticate to both whatever security tools we want to gather alerts from, and also to authenticate to our ticketing system as well to be able to send a post request there and create a ticket. In this case, a couple different things we need in our database. We're going to need a checkpoint value, first of all, as I mentioned earlier. We're also going to need an alert mapping schema, and I'm going to touch on a little bit more about what that is, what kind of information we need to have there in a little bit when we go through this step by step. Of course, we have our ticketing system, so this is where we're going to be recording the tickets and having all that information ready for our analysts to pick up. And finally, this last icon could represent any security platform that we want to collect alerts from. In this case, I'm going to say that we are wanting to collect alerts from an EDR platform, and that's what we'll refer to as we go through an example of this workflow execution. But remember, this can be anything that you want to integrate with as long as there is an API available. Okay, So we went through our procedure, our pseudocode. Now we're aware of what components are going to play a role in this workflow. So now let's start to actually visualize this. Well, first of all, I have to say the workflow we've been talking about really is two workflows. So that's what I have represented here. We have one workflow that's dedicated to querying the EDR tool in this case, and ultimately making a ticket that corresponds to any alerts we discover from that tool. And we have a second workflow that is dedicated to closing the alert, or essentially syncing the status between the ticket that the analyst is directly working on and the original alert in the EDR tool. So here's the same steps that we started to map out in our pseudocode, from things such as collecting the credentials that we need, getting that checkpoint value and actually performing the query, ultimately getting everything ready with that alert data to finally create a ticket. So what we're going to do now, just to see how all of these pieces come together, how they interact and in what order, we're going to go ahead and take these 8 steps for the first workflow and step through them a little bit more slowly. I do also want to mention, I have these steps organized here that were the same as the previous slide, now in this vertical layout. If you do purchase some sort of Soar software or platform, this is the view you're probably going to be most familiar with, this left-hand section of the screen here. You're going to be able to create your workflows in a way where you visually see these pieces together, how they interact with each other, in what order. So we're going to take that sort of visual approach here and represent what executing this particular workflow actually looks like. So what we're going to use here, let's say that this blue box represents the running execution of our automation scripts. We can think of this as the memory of the executing program. And we're going to drag different things that we need into here as necessary. Again, here is our secrets manager, our database, our ticketing platform, and in this case, this will be our EDR tool that we want to query and get alerts from. All right, so let's go through this. So the first thing we need is we need to get everything prepared and ready to ultimately send a GET request to the EDR tool to get any new alerts that have occurred. So what do we need to do that? Well, first of all, we need to be able to authenticate against it. So we need to send a GET request to our secrets manager, and that will return our API key that is used to access the EDR tool. Then, as I mentioned earlier, we also need to grab a checkpoint value. This is how we avoid the possibility of duplicate alerts. We want to make sure we know which alerts we have already handled. So we reach out to the database, we get that checkpoint value. Now, I did refer to the checkpoint value earlier as a timestamp, but just so you're aware, checkpoint value doesn't necessarily have to be a timestamp. This really depends on the particular tool and API that you're working with. The checkpoint value can be anything that ensures that you are never going to process the same alert twice. So another common example of what it may be, let's say that the tool has alert IDs that are sequential and can be sorted. You may use that as your checkpoint value. So it could be that your checkpoint value is alert ID 725. That would mean that on the next run of the script, we only want to query alerts that have an ID that is 726 or greater. So it depends on each scenario. You have to look through your API documentation to determine what makes most sense. But let's say we have our checkpoint value. Now we have everything we need to actually make that query against the EDR tool. So we'll go ahead and do that. And what that will do is return some alert data to us. Now here I am calling that raw alert data, and I'll explain why in a moment. Before we get to that though, let's go ahead, take our new checkpoint value. So this would be the current time, or maybe if we're using that approach of using alert ID, maybe it is the highest alert ID that we just received in the HTTP response from the EDR tool. Whatever our new checkpoint value is, we want to save that to the database so it's ready for us to make our next query on the next run of this automated workflow. All right, so now let's handle this raw alert data. So what I mean when I say raw alert data is I mean at this point we have the alert in the format as defined by the EDR tool. But that may not be how we want the data to be formatted when it's actually placed in the ticketing platform. Because every security tool, really not even just security tool, any IT tool in general, has different field names, different formats, different ways of representing data. And ultimately, we want to have a common set of field names to place into our ticketing system, not only to make life immediately easier for our analysts in terms of locating certain values, but also for purposes of compliance or reporting in the future. If we have different column names or different field names, depending on where the alert came from, it's going to become extremely difficult for us to summarize that data later on. So what we have to do is get an alert mapping schema, which we have stored in our database. And when that's returned to us, what that essentially will be is a translation of field names from the tool that we just queried to field names that are used in our ticketing system. So we'll have our automation script apply that mapping, and we'll end up what we refer to as the normalized alert data. At this point, it doesn't matter where the alert originally came from. We're using the same set of field names, and the ticketing system will now be able to properly process and digest these values. So we're almost ready to send that information to the ticketing system. But of course, before we can, we need to be able to authenticate to it. So we'll reach back out to the secrets manager. We'll get an API key that allows us to do that. And now finally, we're able to send, in this case, a post request that has the information that is needed to create the ticket. All right, so we just stepped through a complete workflow. So here are some other examples of use cases you may want to consider for automation that are related to process management. For the sake of time, we won't be stepping through all of them in the same way that we just did, but here are other ones you want to explore or have in mind. So things such as requesting permission from a user to proceed with an incident, and relating to the second bullet as well, handling any process related for change management. So let's say, for example, if you do want to automate some sort of action that is performed through the incident response process, but you need permission or you need to record that change before you can do that, we can have the automated workflow create a new ticket. We could have it send a prompt or send a request for permission, whether it be through email or through integration with whatever messaging system you use, maybe Microsoft Teams, maybe Slack or something similar, and handle the response in an automated fashion. We could also record any audit logs or any information about what steps have been performed by the automation for compliance standards, and also to help our analysts just understand what has been performed if they are looking through those notes. So now that we've covered that, let's move on to alert enrichment, and we are going to approach this in a very similar way. I'm going to start off by looking at a common scenario that I'm sure all of us face with our security teams. So let's say that upon receiving an alert, SOC analysts search for contextual information related to any alert indicators, such as relevant IP addresses, file hashes, domain names. For example, when an alert involves suspicious activity associated with an IP, analysts search for reputational information about the IP to help determine if the activity is malicious. So what we're going to do is follow the same exact process that we did before to build an automated workflow. So let's go through those steps again. So for the first thing we want to do is we want to not yet think about automation. We want to just focus on what is currently performed manually for this use case. What is our current procedure that our security team has outlined? So in this case, for the sake of simplicity, let's say that we're talking about just IP addresses in this scenario. So what we would want to do is first identify IP addresses that are relevant from the alert details from that ticket that has been created. We want to then perform a few different queries, gather information in a few different ways about that IP address. So this is by no means a complete list of the things that a security team may do to gather information about an IP, but here are some actions that they likely would want to take. Actions such as looking for any past alerts that involved the same IP address, looking for who is information, looking for any threat intelligence about that IP address, whether that is open source intelligence or OSINT, or perhaps paid tools as well, and then taking all of these results that are gathered and adding these results to the incident ticket to provide additional context. Finally, there's actually quite a few actions we could take if the IP is determined to be malicious. Here's one example of an action that we may want to perform or that an analyst may do. They may raise the incident ticket priority if an IP address is discovered to be bad. I put bad in quotes there because, of course, that is a very subjective term. We're going to touch on that a little bit more later on. And then the analyst may save that indicator information for use in future alerts, so we don't have to perform the same queries. Again, we can immediately know some of the information that we found previously. So we're following the same process as before. We would take that and we would translate it to pseudocode. Again, I'm not going to go through all of this with you right now, because we're going to represent this in a more visual friendly approach in a moment. But this is definitely a step you want to take. Start to design what that program is going to look like. So let's touch on our resources that are involved in this workflow again. What specifically are each of these resources going to be holding in this scenario? Of course, we still have our automation scripts and our API tokens in the secrets manager. In this case, for a database, we may actually have some private threat intelligence in that database. This may vary depending on your organization and what other workflows you currently have set up. I would say at minimum, we want a database that is able to associate past indicators that we have found and past alerts that they have been associated with. So let's say at minimum we have that. We're able to look up when an IP in this case was associated with an alert previously. But at most or additionally, you may also have some threat intelligence in that database. So things such as maybe free feeds that are being downloaded and processed and stored in that threat intelligence database. And actually, we're not going to have time, unfortunately, to get through that today, but you could have your Soar platform have some workflows that are dedicated to downloading, processing, and storing threat intelligence as well. We still have our incident ticket, and in this case, some third-party tools that we may want to integrate with are threat intelligence tools, Wiz tools, etc. Let's take a look at a visual representation of this workflow. We're going to go ahead and do the same thing as we did in the previous use case. We're going to take these steps and see how they actually interact with each other, how the result of one impacts the execution of the next, and so on. Let's go ahead and move this over to the left-hand side of our screen again and step through this one at a time. All right, so as we start to execute this workflow, we already have a ticket that has been created, likely through the process that we established in the previous use case and in the previous workflow. So at this point, we have some alert data. Let's say that this is the normalized alert data that we got from the ticketing platform. The first thing we need to do is identify IP addresses that we want to enrich. So when we extract these IP addresses, that could be in a couple of ways. If we did a really good job of normalizing the alert data previously, then hopefully we already have some field names that indicate where the IP values are stored, and we can simply pull those out. If not, maybe we use regex to extract those, but either way, we end up with our extracted IPs. Now there's a few different actions we want to take to enrich this IP information. For the sake of time and visual representation here, I have limited the actions that we're going to take here, but keep in mind, this is very modular and you could add on as many automated actions as you want. So let's say that one thing we're going to do is search our private threat intelligence database and get any past alerts or past information that we found related to this IP that we discovered. We'll go ahead and send that GET request and get a response that gives us that information. Similarly, we want to, let's say, query open source intelligence. So we likely need to provide some sort of authentication information to that tool. So to do that, we can reach out to our secrets manager, get back our API key, and that then gives us the ability to send a GET request to that tool as well, that third-party tool, and it will return some information to us. Now here's the trickiest part. How do we determine if the IP is bad, such a subjective term? Well, honestly, the process of determining how you can automate this decision point is an entire use case all in itself, for which you'd want to follow the same strategy. So you'd want to go to your analysts, to their current procedures and playbooks that they've established, and look at how they currently determine, after they've gathered this information manually, if an IP or any other sort of indicator is malicious. Ultimately, I can't tell you the exact answer here because it does depend from organization to organization. What I can tell you is that you are going to want to ultimately come up with some sort of formula that gives you an output, whether it is a numeric scoring for the indicator, whether it is simply a categorization of malicious to benign to anything in between. You're going to want to come up with some sort of score for the indicator. There are some tools I will mention, whether they're open source intelligence or third-party tools that are paid, that do provide for you already some scoring or some numeric values associated with the reputation of the IP. So maybe that you just take advantage of that, take that value directly from the response that we receive from our request, or it may be that you take an average of them, that you combine them with some of your own custom factors. Either way, we end up with some sort of scoring for the IP. We're going to go ahead and take all of the information we've gathered and the scoring that we determined and send that to two places. We're going to send it to the ticketing system and to the database. These will both be post requests, so the database will now have this information for future use, and the analyst will have a way to view all this information that was found in the automated workflow. Now at this point, again, this is just one example of what you may do if the IP has been scored in a way that surpasses whatever threshold you've established and is considered bad. One thing we may want to do is raise the incident priority, so that way analysts are immediately notified that this is something that requires some immediate attention, that it is perhaps more critical to investigate this alert as opposed to other alerts that have come in that did not surpass this threshold. So we'll go ahead, send a post request again to the ticketing system to indicate that the priority should be escalated. All right, so some other use cases related to alert enrichment. So if you have a CMDB, that's going to be a great source to gather some additional information about your alert. This could help you determine the priority of alerts. Say you have an asset that is affected by an incident that you know contains PHI data, or you maybe have a workstation that is being affected by some malware. You probably want to apply a different priority to it if that workstation belongs to a CEO versus if it belongs to an intern. So this information can help you take some actions, raise priorities, etc. If you have a SIM, or if you just want to query some other log data that exists in some other space, take whatever queries your analysts currently execute manually, put that in your automation workflow. We can have the Soar platform actually perform that query for you. If there are some dynamic pieces to that, some variable pieces, that's okay, we can account for that. And we can take those results and put that into the ticket. So that way, like I said before, the analyst can hit the ground running, skip straight to analysis, so don't have to spend time logging into that system and running those queries themselves. And again, another example, let's say we have an incident involving a potentially malicious file. If you have a sandbox that has an API, you can go ahead, send a request to run and execute that file and record results and add that to the ticket as well. All right, we've reached our final section. I know we are running low on time, so we're going to step through this much more quickly than the previous two scenarios, but I do want to touch on containment actions. So what this means is...
Sorry, Jacob, I just wanted to thank you. Most people are still on, so very, very relevant content. But I do want, for those who do have to drop off at noon, I just wanted to remind you that you will receive the survey, and if you do want to follow up with the security team, that's the place to do that. So I just wanted to make sure folks remembered that before you continue, Jacob. Thank you.
Sure, and I know we are low on time, so I'll skip forward a little bit. The process for coming up with these workflows, again, exactly the same as the process we established before. You're identifying the use case first. You're looking at the current playbook, the current procedures that your analysts are currently performing manually, and then you're looking to move into Pseudocode and ultimately moving into this representation of the workflow. So here's just two workflows, two examples of automated containment actions, and they follow the exact same pattern that we've seen before. First one, let's say that we want to use an EDR tool to quarantine an infected endpoint. The way we do that is we first gather any credentials that are necessary to authenticate to the management console of the EDR platform. We get that from the secrets manager, go ahead and make the request to actually quarantine that endpoint. So that would be a post request. And then we can wait for the response and record confirmation of that action. You could actually send that as a post request to the ticket. So there's a note there for the analyst to see. Same exact pattern for a firewall policy change, for example. So maybe this is a scenario in which you want to block an IP address. Okay, so we've talked through a few different scenarios and categories of use cases, but now let's talk about actually building a complete workflow. How do we handle an alert from end to end? Thing is, a Soar platform requires you to think in a very modular and logical approach. So we've talked about all of these different actions that we can now automate, things such as retrieving new alerts and creating tickets, taking containment actions like quarantining an endpoint. And now we have all of these different puzzle pieces that we can fit together or remove as necessary. Ultimately, the goal here is to make your security team and their incident response more efficient. So typically you would approach this by looking at some alerts that you want to automate the incident response process for. And then you can pick and choose, take these different pieces that we've written and combine them in a way to complete to build the complete picture of what that workflow will look like. So as an example of that, here is a workflow that represents gathering an alert from an EDR tool and taking some approaches that we've discussed previously. So this covers all three of these categories that we talked about: the process management, the alert enrichment, the containment actions. Let's say here we are gathering the alerts. Of course, first of all, we're creating a ticket for the analysts to work with in the ticketing system. Then we're searching for any relevant threat intel to enrich any indicators associated with that alert. Another thing we may do for enrichment is executing a file in the sandbox and recording the results in the ticket. At that point, we can reach a decision point and we can have our workflow diverge depending on the results of the previous completed steps. If we find that the alert is not, in fact, a true positive, that the file was not malicious, maybe we go ahead and just close the alert right away. This means that we saved our analysts a lot of time. They're able to focus on actual alerts that require attention. If it is malicious, we can go ahead and move towards possibly quarantining the endpoint if we get approval to do so. So again, here we're combining all three of those aspects, right? Process management, the enrichment, and the containment actions. All right, I know we gotta close out very soon, so very quickly, let me show you some numbers that we gathered from our actual MDR service, from our practice. So the analysts on our team were kind enough to help me gather these numbers represented by the human icon. I gave them three very specific actions to take and to record themselves or to time themselves performing: creating a ticket, searching one source of threat intelligence, and quarantining an endpoint. And then I used our actual workflow and timed the execution of these workflows as well. As you can see, in every scenario, even with skilled analysts, the automation is much faster. And again, these were very isolated, simple actions, right? Just imagine this, multiply this against however many alerts you deal with on a daily basis, however many queries you perform to enrich those alerts. As you can see, it's going to add up very quickly. You're going to be able to save yourself a lot of time, close those incidents much more quickly, and therefore reduce risk to your security or to your enterprise and get more value out of these resources that you already have. All right, with that in mind, thank you so much. I'm going to turn back over to Joe to help close us out.
Awesome, Jacob. Thank you so much. A lot of great content, and again, so timely for our customers. So thanks for all the work you did there. If we just advance the next couple of slides, I mentioned this, folks, on the post-webinar survey. If you want to take advantage of this whiteboard session to talk to Jacob and team members about automation, just check that off in the survey. Also, you'll see in there just opportunities to chat about any other topics, including some free-form text if you want to ask some questions. So with that, Jacob, I think we're ready to close out. On the next screen, if you have questions, you'll see contact information on the following page. You can reach out to Jacob, myself. Jacob, if you just advance one more time, you'll see a contact email. If you don't have your account representative email, you can also email solutions@neweratech.com. So all, once again, thank you very much. I hope you found this useful, and we'll hopefully see you next time. Take care.